Autophagy plays a vital role in maintaining proteostasis, the delicate balance of protein synthesis, folding, and degradation that underpins cellular function. As we age, the ability to maintain this balance declines, leading to the accumulation of misfolded, damaged, or aggregated proteins. These aberrant proteins are not just byproducts of wear and tear. They actively disrupt cellular operations, contribute to inflammation, and trigger the cellular dysfunction that underlies many age-related diseases. Autophagy serves as a powerful internal mechanism for clearing these protein aggregates and restoring order, especially in long-lived, non-dividing cells like neurons. Within the proteostasis network, several quality control systems work together to keep proteins functional. Molecular chaperones help fold proteins correctly. The ubiquitin proteasome system degrades small or short-lived proteins, and autophagy handles bulkier, more complex cleanup. Autophagy is uniquely equipped to remove large protein aggregates, insoluble complexes, and dysfunctional organelles that the proteasome cannot process. These are precisely the types of damage that tend to accumulate in aging tissues and are particularly harmful in the brain. In neurodegenerative diseases like Huntington's, Alzheimer's, Parkinson's, and amyotrophic lateral sclerosis, ALS, toxic protein aggregates form inside neurons and glial cells, interfering with their function and eventually leading to cell death. Autophagy helps mitigate this threat by recognizing these aggregates, often tagged by ubiquitin, and delivering them to lysosomes for breakdown and recycling. Specialized forms of autophagy, such as agrephagy, the selective clearance of protein aggregates, become especially important in this context. Enhancing autophagy has been shown in animal models to reduce the buildup of Huntington, tau, and alpha-synuclein proteins, pathological hallmarks of several brain diseases. More broadly, autophagy supports proteostasis by preventing the accumulation of oxidative damage. As we age, oxidative stress increases, damaging proteins and impairing their folding and function. Autophagy selectively removes oxidized and misfolded proteins before they can aggregate, which not only reduces toxicity, but also prevents cellular stress responses that lead to inflammation and senescence. This quality control helps maintain the functional capacity of cells across organs, from the brain and liver to skeletal muscle and skin. Importantly, the relationship between autophagy and proteostasis is not one way. The health of the autophagic machinery itself depends on proper protein folding and the integrity of lysosomes. If these systems become overwhelmed or impaired due to genetic mutations, chronic inflammation, or nutrient overload, the cleanup process falters. This creates a vicious cycle where damaged proteins accumulate, further inhibiting autophagy and accelerating aging. Interventions that restore autophagy can help break this cycle and re-establish cellular balance. There is also growing evidence that enhancing autophagy improves not only the quantity, but the quality of the cellular proteome, the total pool of functional proteins within a cell. By ensuring that only correctly folded and unmodified proteins remain active, autophagy supports enzyme activity, receptor sensitivity, and intracellular communication, all of which tend to decline with age. In tissues with high turnover, like the intestinal lining and immune cells, this proteostatic control helps preserve resilience. In tissues with low turnover, like the brain, it is absolutely essential for long-term stability. In sum, autophagy acts as the cell's internal purification system, selectively removing toxic protein aggregates and preserving proteome integrity. By doing so, it offers a powerful safeguard against age-related decline, especially in the nervous system where proteostasis is most fragile. Enhancing autophagy not only reduces the risk of neurodegeneration but also preserves the sharp, adaptive functioning of cells in all tissues. Aging might naturally bring molecular damage, but with active autophagy, cells can stay clean, clear, and capable, extending the health of both mind and body.